Welcome to the deep dive. So if you've been paying any attention at all to global headlines, or maybe if your favorite apps just, stopped working, you know that the internet had a really shaky week recently. Today, we are going to do the ultimate deep dive into what we're calling the week the internet stumbled.
It really did stumble.
It did. The topic is this unprecedented series of major, hours-long outages that hit the world's biggest providers. We're talking Amazon Web Services, Microsoft Azure, and Cloudflare.
All in quick succession.
Exactly.
Yeah.
And these weren't just, little server hiccups. They were serious structural failures, and they revealed a pretty terrifying fragility right at the core of the whole digital economy. So for our source material, we've gone deep. We've synthesized the technical postmortems, all the details on AWS's automation bug, Azure's configuration fault, Cloudflare's issues, and we're putting them right alongside these.
And that's really our mission here. It's to connect all those dots. Because we need to move beyond just understanding what piece of code failed.
Right.
We have to understand why the impact was so massive, so global, why it forced millions of people offline and even disrupted critical national infrastructure.
So we're tying the technical causes to the systemic risks.
Exactly. The risks that experts are arguing stem directly from this deep concentration of the internet into just a handful of providers. What's so fascinating here, I think, is how these systems that are designed for ultimate efficiency and automation.
They can just turn on themselves.
They can. We're going to explore how something as seemingly small as an empty DNS record or a simple configuration mistake can just ripple through everything, proving that the very scale we rely on for speed and cost, well, that's precisely where our greatest vulnerability is.
That structural weakness, that is the core insight we need to pull out of this today. And I think we have to start with the incident that really kicked it all off. The hours-long AWS failure that centered on US East 1. When we say AWS, we really do mean the backbone of the modern internet.
Oh, absolutely.
And when we talk about the US East 1 data center region, the one in Northern Virginia, we're talking about maybe the single most critical piece of digital real estate in the world.
It's Grand Central Station.
It is. And its failure affected thousands of sites, thousands of applications, everything from messaging services to banking platforms.
Yeah.
But the first question has to be technical. After all the smoke cleared, what did Amazon itself say was the specific technical root cause that brought this whole colossal system to its knees?
Well, their postmortem was actually very detailed, and it confirms the issue was homegrown. The core failure was something they called a latent defect, a hidden bug.
Just sitting there.
Just sitting there, hidden inside the automated DNS management system that controls something called DynamoDB.
Okay, so let's unpack DynamoDB for a second. What is that?
So DynamoDB is AWS's own database system. It's a high-performance NoSQL database. Millions of applications rely on it for, real-time data access.
And to handle that kind of scale, we're talking millions of reads and writes every second. You can't have a human managing it.
No way. It has to rely on this super sophisticated, self-regulating automation layer.
So this automation, it isn't just a convenience. It's completely essential for it to even function at that level.
It's essential. This system is responsible for maintaining literally hundreds of thousands of DNS records all over the world.
And DNS is, just as a quick reminder, the phone book of the internet. It tells your request where to go.
Exactly. And the DynamoDB automation is designed to constantly watch the system, add capacity when needed, handle hardware failures on the fly, and just generally distribute traffic efficiently. It's meant to be self-healing.
Okay, so that brings us to the moment it all fell apart. If this thing is supposed to be hands-off and self-healing, what was the fatal flaw? What let a local problem in Virginia cascade and have a global impact?
The fatal flaw was identified as, and this sounds almost too simple, the existence of an empty DNS record.
An empty record.
Yeah, think of it like a blank entry in that phone book. Just an empty line where a valid number should have been. And in a configuration as massive as US East 1, that one empty record was basically poison.
Wow.
The bug was that this incredibly sophisticated automation system, specifically a component called the DNS planner, it just didn't know how to handle that empty state.
It didn't ignore it.
It didn't ignore it and it didn't fix it. Instead, this defect basically forced the automation into an infinite loop. It just got stuck. It was trying to process an invalid input over and over and over.
That's actually terrifying. The very mechanism that's supposed to guarantee uptime gets jammed by a single blank line.
That's it, precisely. And because that DNS planner system was stuck, it couldn't update the IP addresses that all the customer apps needed to find and talk to the DynamoDB server.
So it broke the connection.
It broke that crucial connection between the application and its data.
Mm-hmm.
And because the automation was completely locked up, the only way out was for humans to intervene. It took engineers hours to find the single point of failure and manually bypass the broken automated system.
And Amazon's response to this tells you how serious it was, right?
Oh, absolutely. Their immediate fix was to disable that DynamoDB DNS planner and the enactor automation worldwide.
Worldwide.
Imagine the risk of that. They suddenly had to put a system that was fully automated under massive manual oversight, all so they could implement fixes to make sure that one specific bug could never happen again. It just shows you how a complex system, when it faces something it doesn't expect, like an empty record, it defaults to catastrophic failure, not, a graceful shutdown.
The tech details are fascinating, but it's the real-world impact that really drives this home for people. I mean, this wasn't some background IT problem. It was a societal disruption.
It really was.
We saw all these high-profile services get hit. Signal, Snapchat, Roblox, Duolingo. Banking sites were struggling. Even smart home stuff like Ring doorbells, they just went dark.
Right. People couldn't see who was at their own door.
Exactly. And the stats from Down Detector were just staggering. Over 2,000 companies affected, something like 8.1 million reports of problems from users.
And we can narrow that down to one single perfect example of this deep dependency we have. The case of 8 Sleep.
The smart bed company.
The smart bed company. So they sell these beds that use internet connectivity to let you adjust the temperature and other things through an app on your phone.
Cool, yeah.
Well, during the AWS outage, customers suddenly found they couldn't turn off their heated mattresses or change the bed's position. Because the command wasn't running locally on their phone or on the bed, it was trying to talk to the application's control layer, which was hosted remotely on AWS in Virginia.
You're kidding me. You literally couldn't turn the heat off on your own physical bed because a server hundreds of miles away was broken.
That is an intense level of outsourced control, isn't it? The company's CEO had to go on X and apologize, and their solution was actually really instructive.
What did they do?
They realized the risk of being so centralized. So they immediately pushed out a software update that allowed users to control the critical functions of the bed via Bluetooth, a direct local connection.
A backup plan.
A backup plan. They were forced to build redundancy outside the cloud model because the centralized cloud model had completely failed them. That's the perfect practical example of a single point failure.
And that really highlights the transition we need to make in this conversation. It shifts from how do we make AWS better to how do we deal with the vulnerability that comes from this massive centralization. That's the perfect pivot because the AWS incident, it wasn't a one-off. It wasn't an isolated event.
No, not at all.
It was followed very shortly after by major, completely separate issues at both Cloudflare and Microsoft Azure, and the collective impact of that. 3 distinct failures at 3 crucial layers of the internet all in a row. It created this feeling, especially among regulators, that they were watching systemic fragility play out in real time.
The sequence was just jarring. It immediately changed the conversation from, seeing these as isolated tech problems to seeing them as symptoms of a much bigger market-wide issue.
Okay, so let's analyze Cloudflare next,
Right.
because it's a different part of the stack than AWS or Azure.
It is. Cloudflare is a dominant content delivery network, a CDN. So this means it doesn't just make content load faster, it provides the crucial security layer. DDoS defense, firewalls, all of that for a huge chunk of the modern internet.
It's like the traffic cop and the security guard.
It's the traffic cop and the security guard for millions of websites.
So when Cloudflare fails, it's not just that the website is slow, it's that the security layer itself breaks down. What was their explanation for what happened?
Cloudflare said it was an internal service degradation. It seems it started with an issue related to their support portal provider, of all things. But what's really crucial to understand here is the concept of the control plane.
The control plane.
The control plane is the brain. It's the system that manages, configures, and routes all the traffic flowing through Cloudflare's massive global network. And the issue wasn't that the network nodes couldn't pass data along. It was that the centralized control system, the thing telling the nodes what to do, it started to fail.
So the body was fine, but the brain was having a problem.
That's a great way to put it. They contained it pretty quickly, but for a while, it just crippled their ability to act as that security intermediary. And just like AWS, they were very quick to confirm it was an internal problem, not a malicious attack, another internal process failure.
And The result was that bizarre user experience that so many people reported on major platforms, X, ChatGPT, Spotify, Canva, even the big telecom providers. People kept seeing that strange error message.
The please unblock challenges.cloudflare.com to proceed.
Yeah, that's What did that actually mean?
That message is key. It means that the security and challenge systems, the very service Cloudflare provides, were malfunctioning. The system couldn't verify the user, it couldn't complete the Canva TCHA, it couldn't run its normal security checks.
So it's just stuck.
It was stuck in a loop. It was basically saying, I can't confirm you're a legitimate user, so I'm going to block you, even if the website you were trying to reach was perfectly fine on its own server.
It was the gatekeeper who locked the gate and then lost the key.
Exactly. And that failure really highlights the risk of relying on one centralized company for security. But the incident that really gave the regulators undeniable evidence, that was the Azure failure, which happened just days after AWS.
Yep.
The Azure failure was the third punch. And it basically confirmed everyone's worst fears about this widespread systemic vulnerability. It was another major global outage, and it hit around 4 p.m. UTC on October 29.
And again, what was the cause?
Just like AWS, it wasn't an attack. It was identified as a configuration fault in a service called Azure Front Door.
And Azure Front Door is, what, Microsoft's version of a CDN?
Yeah, it's their global CDN and application acceleration platform. It's designed to deliver services like Microsoft 365 and Xbox Live really fast with low latency, and it serves thousands of third-party clients too.
A configuration fault sounds so administrative. How does a simple internal mistake like that instantly take down global enterprise systems?
It's all about the scale and the speed of propagation. You have to remember, in these hyperscale environments, engineers are making thousands of configuration changes every single day.
And those changes are pushed out automatically.
Instantly across the entire globe. And in this case, a configuration change that was probably meant to do something minor contained an error, a bad line of code.
And because Azure Front Door is that global gateway.
That single bad instruction was immediately implemented everywhere on the planet. The system did exactly what it was told to do. The problem was it was told the wrong thing.
And the cascading effects here were huge, right? Especially given how dominant Azure is in the corporate world and the public sector.
Absolutely. The outage immediately hit core Microsoft services. Microsoft 365, which is like the nervous system for so many businesses, and Xbox Live, their huge gaming platform.
But the real worry for governments was the third-party impact.
That was the true concern. We know for a fact this one configuration fault disrupted telecom networks, it messed with airline check-in systems around the world, and it took down public sector platforms that rely on Azure for essential government services.
So if you just connect the dots across these three incidents,
you get a perfect spectrum of how these things can fail. You have a latent bug in a complex automation system at AWS. You have a control plane failure at Cloudflare. And then you have a simple human error in change management at Azure.
Three totally different technical problems.
But all resulting in the exact same catastrophic global cross-industry disruption. The common denominator isn't the code, it's the concentration.
And that realization, the concentration itself is the core vulnerability. That's what immediately shifts this whole conversation away from just IT troubleshooting and into really a political and economic debate.
It has to.
So what does it all mean when the two dominant players, AWS and Azure, both fail so publicly, just days apart?
It means the debate instantly moved beyond asking companies to just, patch your bugs. It became a serious discussion about market structure and whether we need regulatory intervention. These outages gave regulators all the evidence they needed for this concentration problem they've been worried about for years.
Yeah.
There was a great quote from Dr. Soulette Dreyfus, a specialist in this area. She said the outages really showed the world's deep dependence on single points of failure. Which is such a profound contradiction of how the internet was supposed to work.
Right. The whole original design of the internet was about decentralization.
Yeah.
It was supposed to be resilient to route around any damage.
Exactly. A mesh network. If one node failed, 10 others could pick up the slack. But our dependence on this, handful of giant tech companies to provide everything, storage, applications, delivery, security, it has effectively re-centralized the internet.
We've built these massive, beautiful castles, but they're on very shaky foundations.
That's it. AWS has about 30% of the market. Azure is climbing fast. And their dominance gives us incredible scale and performance, but it comes at this incredibly steep cost of single-point fragility. They are effectively too big to fail, and yet they keep failing.
Which brings us directly to the political response. We saw these really forceful calls for regulatory action, especially out of the UK and Europe, where they're already so invested in this idea of digital sovereignty.
Hmm.
We should probably get into the specific arguments being made by people like Nikki Stewart from the Open Cloud Coalition and Mark Boost from SIVO.
Yeah, their arguments are very specific, and they target the economics of how the cloud market is structured.
So let's start with Nikki Stewart. Her argument was about systemic risk. Right?
Right.
She argued very clearly that having these successive outages at this scale just exposes the systemic risk of Europe's, frankly, overwhelming dependence on just two dominant U.S. providers. For her, resilience can't come from just hoping these companies get better. It has to come from choice, from market diversification.
She's saying the efficiency we gain by consolidating isn't worth the risk anymore.
Exactly. The cost of failure disrupting entire economies now outweighs the efficiency benefit. And she specifically called on the UK's Competition and Markets Authority, the CMA, to not just keep investigating, but to actually accelerate and implement remedies to force a more open, competitive, and interoperable cloud market in Europe. And then Mark Boost's argument takes it even a step further, tying it right into national security, this idea of digital sovereignty.
Yeah, his argument is framed as an urgent wake-up call, especially for governments. He argues that this over-reliance on U.S. hyperscalers is fundamentally compromising critical national infrastructure.
How so?
Because when these incidents happen, a country's digital sovereignty, its ability to control its own data and systems, is just gone. The control plane, the brain, is physically and jurisdictionally located somewhere else.
He had those really sharp examples of outsourced risk.
He did. He said a simple configuration error originating in a data center thousands of miles away should not have the power to ground flights at Heathrow or disrupt parliamentary systems in Scotland.
That reframes it completely. It's not a tech bug anymore. It's a strategic national vulnerability.
It is. These are real, tangible threats to a country's ability to function, all because the underlying platforms are concentrated and outside of local control.
Let's make that real for a second.
Yeah.
How exactly could a configuration error in Azure ground flights at Heathrow?
It's all about the dependency chain. Modern airports rely on massive cloud applications for everything. Check-in systems, baggage handling, runway sequencing, air traffic coordination.
All of it.
All of it. So if Heathrow is using an Azure-hosted platform for, say, their check-in and gate management, and that Azure Front Door configuration fault stops those applications from communicating, the systems just freeze.
And you can't board planes.
You can't check people in. You can't manage the baggage flow. You can't launch aircraft. It causes cascading delays. And yeah, it can absolutely ground flights. The dependency is total.
So the solution they're proposing is diversification, but that's hard to force. What are the specific regulatory tools they're demanding to break this vendor lock-in?
This is where we have to get into the technical economics of the cloud. The reformers are demanding three main things, and they're all designed to make it easy and affordable to spread your workloads across multiple providers, a multi-cloud strategy.
Okay.
First, and this is the big one, is tackling egress pricing. Egress pricing is the fee that cloud providers charge you to move your data out of their cloud.
The Hotel California problem. You can check in, but you can never leave.
That is precisely it, and it's the single biggest thing stopping competition. The costs are just astronomically high.
So if you're a government with petabytes of data on AWS and you want to move half of it to a smaller local cloud provider for resilience,
the egress fees AWS would charge you for that transfer could be millions of dollars. It makes diversification economically impossible for many. So regulators want to mandate much, much lower, fairer egress pricing.
okay, that makes sense. And what about the other two reforms? Interoperability and data portability.
So mandatory interoperability is about making sure the systems and APIs that AWS and Azure use can easily talk to other cloud providers. Right now, the big players often use their own proprietary tools and standards.
Which creates technical lock-in, not just economic lock-in.
Exactly. If your entire IT setup is customized to only run on Azure's special flavor of services, moving to another provider is a massive, expensive engineering project. This would force them to play nice with competitors.
And data portability.
That's related. It focuses on the data itself, making sure customers can get their data back in a universal format that can be instantly used by another provider without having to be converted or modified. All three of these things are designed to reduce the friction and the cost of either switching providers or adopting a true multi-cloud strategy.
Which explains why that UK Competition and Markets Authority probe that started in 2023 is so important. They are looking at the dominance of AWS and Microsoft Azure, and they're expected to deliver these kinds of structural remedies next year.
It's a critical inflection point. The whole conversation around cloud strategy is finally shifting. It's moving away from just focusing on scale and cost, which is what got us into this vulnerable position, and it's moving towards focusing on resilience and strategic autonomy.
Driven by Europe's push for digital sovereignty.
Exactly. This regulatory movement sees diversification not as a luxury or a cost, but as a mandatory prerequisite for national security and economic stability. No cloud provider can guarantee 100% uptime.
Of course not.
But the consensus is clear. Diversification across providers and geographies is the key, maybe the only defense against these kinds of systemic global failures. Hashtag outro.
We reached the end of this deep dive into the week the cloud stumbled. So let's just try to synthesize the core takeaways for you. We looked at 3 totally different technical failures: an automation defect at AWS, a configuration fault at Azure, and a control plane problem at Cloudflare. And all 3 of those distinct failures pointed to the exact same structural weakness: the intense concentration of the Internet's critical backbone in far too few hands.
Yeah.
The convenience we got from all that consolidation has now shown itself to be a pretty profound and dangerous vulnerability. And it affects everything from our smart beds to air traffic control.
And the critical lesson here, as always, is that the knowledge is most valuable when you actually understand it and apply it. For governments, for big companies, the lesson is that the only real way to mitigate this is a proactive strategy of diversification.
Spreading the risk.
Spreading the risk. Spreading workloads across providers and geographies so that one company's internal mistake can't paralyze critical services for the entire globe. The internet was designed to route around damage. Our current digital world is optimized for speed and scale, but it's at the expense of that core resilience.
We've looked at the increasing fragility of the internet and this regulatory push for reforms like fair egress pricing and interoperability. And, it leaves us with this final provocative thought, and this is really for you to mull over. If the financial incentive for these huge providers is to maintain that technical vendor lock-in, will regulatory pressure alone really be enough to force the market to diversify? Or are we just structurally locked into a system where the chase for convenience and scale will always trump strategic resilience? And maybe more personally, what steps can you take to identify and maybe mitigate the single points of failure in the critical digital tools and platforms that you rely on every single day? Thank you for joining us for this deep dive into the fascinating nexus of technology, regulation, and global infrastructure. We'll see you next time.